The steel cable was about to snap. 3,000 tons suspended 113 meters in the air, an entire ship hanging above the ground. The engineers had 40 seconds to act before catastrophe. But wait, how did a ship even get up there in the first place? While you're watching this video, somewhere in China, a ship is being lifted to the height of a 30-story building, not by magic, but by something even more impressive, pure engineering. Imagine the following challenge you need to make a ship cross a mountain. Yes, you heard that right, a mountain. China has rivers that cut through entire mountain ranges with drops of over 100 meters and violent currents that destroy any vessel. For centuries, this was considered impossible to navigate. But do you know what happens when you tell a Chinese engineer something is impossible? He builds the tallest bridge in the world, 565 meters above a valley. Look down and you see clouds. He raises hydroelectric plants that generate the same energy as 15 nuclear reactors. The Baihetan plant alone has a capacity of 16 million kWh. He drills tunnels through mountains once considered impenetrable, like the Jinpingshan Tunnel, 18 km of solid rock. He paves highways on the roof of the world at more than 5,000 meters altitude, where the air is so thin workers need oxygen. And yes, he makes ships climb mountains. But let's go back to that ship hanging in midair. How do you lift 3,000 tons like that? The obvious answer would be use a giant elevator. But it's not so simple. You're not just lifting the ship, you're lifting the ship plus the water that keeps it afloat. And that water weighs as much as the ship itself. Nearly 6,000 tons being raised more than 100 meters high. Now the million-dollar question, how do you do that without consuming enough energy to power an entire city? Chinese engineers created a system so ingenious it practically lifts itself. How? With a trick Archimedes discovered over 2,000 years ago. They built a counterweight system, but not just any counterweight. A perfectly calibrated balancing mechanism that makes the ship float up and down as if it weighed nothing. Think of a gigantic seesaw. On one side, the ship inside a steel basin. On the other, massive concrete blocks. When the ship rises, the counterweight descends. When it descends, the counterweight rises. But wait, there's a problem. The tower holding all of this is nearly 200 meters tall, higher than most skyscrapers. And what happens when the sun heats massive metal structures? They expand only a few millimeters, but enough to throw the system out of alignment. Solution engineers installed sensors that detect thermal expansion in real time and automatically adjust the ship's position, a system that constantly corrects itself. And here's the most impressive part. This is not the only system. They built several, each one crazier than the last. At the Three Gorges Dam, the ship lift operates 22 hours a day just for maintenance. It has already lifted thousands of vessels. But an even more insane one exists, the Baihetan ship lift. This one is 199 meters tall, and it doesn't lift one ship at a time. It lifts 3 simultaneously in different stages. It's like a vertical ship production conveyor belt. While one is rising on the first level, another is entering the second, and a third is leaving the third. Maximum efficiency. And do you know how long it takes for a ship to go up 199 meters 10 minutes? But here's what's truly mind-bending. This is only a tiny fragment of what was happening. Let me put it into perspective. While these ship lifts were being built with all their insane complexity of cables, counterweights, and hydraulic systems on the other side of the country, thousands of kilometers away, other engineers were constructing the Baihetan Hydropower station. And it's not just any power plant. We're talking about 16 million kilowatts of capacity, the second largest in the world, built in a geologically unstable canyon where earthquakes are routine, not exceptions. Imagine trying to build something the size of multiple cities while the ground literally shakes beneath your feet. And there's more. At the same time, other completely separate teams were diverting entire rivers, not streams, but gigantic rivers through 2,700 kilometers, crossing 10 provinces. Why? Because southern China has too much water and the north doesn't have enough. The solution: redirect millions of liters of water through underground tunnels that cut through mountains, crossing terrain that shifts with the seasons. And here's the true madness. While all of this was happening, thousands of workers wearing oxygen masks because the air was too thin were building the Qinghai-Tibet Railway across permanently frozen ground at altitudes where you literally cannot breathe properly. They laid tracks over permafrost soil that melts and refreezes, capable of destroying any structure, and still made it work. All of this happening simultaneously. Separate projects, different teams, unique challenges, yet all being executed as if it were completely normal. So back to that steel cable on the verge of snapping at the beginning. In reality, there was never any real danger. The entire system has triple redundancies. If one cable fails, 12 others hold the load. If the power goes out and mechanical breaks, lock everything instantly. The ship can remain suspended for days if necessary. But you know what's truly terrifying? It's not what they have already built. It's what they are planning to build next. And in the next video, I'll show you the most insane one of all a project so ambitious that when the first engineers heard the proposal, half thought it was a joke. If you found this impressive, hit the like button and subscribe because you won't want to miss what's coming next.